This is my second video lesson for Unit 15. In this lesson, we'll be analyzing isomers. Go to page 8 in the class packet. Motivation: what are similarities and differences between these two compounds, and do we expect them to have similar properties? So take a moment to think about it. Learning target: at the end of the lesson, I'll be able to draw different isomers of organic compounds. Homework number 2 will be a junipod based off this lesson. Isomers of organic compounds have the same molecular formula, but different structures and properties. So these two compounds are isomers. They have the same formula and the same GFM. Here are the condensed structural formula to differentiate the two. This is ethanol, and this is dimethyl ether. Notice they have different properties and different applications. Learning check number 1. Which compound is an isomer of this? Pause the video. Resume as completed. You're looking for a compound with the same molecular formula. The answer is choice 4. Learning check number 2. Which two formulas represent compounds that are isomers of each other? Pause the video. Resume as completed. Formula A and Formula B have the same molecular formula but have different structures. Therefore, they are isomers, so the answer is choice 1. Learning check number 3. Which compound has an isomer? Pause the video, resume as completed. The best answer is choice 4 because the larger the molecule or carbon chain, the number of possible isomers increase. There is no isomer for choice 1, 2, and 3. You can try moving the atoms around. There is no isomer. There is an isomer for choice 4, which is this one. Now we're going to look at 3 common misconceptions when it comes to identifying isomers. Let's look at the first one. Are these two compounds isomers? Let's analyze it. The right side of the molecule seems to be the same. Let's look at the left side. At a glance, the atoms bonded to the carbon highlighted red seem to be at different places, but this is deceiving because single bonds can rotate. Because of that, these two compounds are actually not isomers. They're the same compound. One way to visualize this is that you have to think about these molecules in terms of a 3D shape rather than 2D on a piece of paper. So let's draw the 3D shape of each molecule. The blue circle represents the hydrogen, the red circle represents carbon, the green circle represents chlorine, and the black line represents the bond. So notice in this structure, the chlorine's on top, and in this structure, the chlorine's on the bottom. If we rotate this single bond, notice that both compounds are now completely identical. Single bonds can rotate freely because they only consist of sigma bonds. If you recall from Unit 5, sigma bonds have electrons between the atoms. Double and triple bonds, on the other hand, cannot rotate because they have sigma and pi bonds. Pi bonds have electron above and below the bond, and this prevents the bond from rotating, because if it tries to rotate, it will break the pi bond. Let's look at the next example. Are these two compounds isomers? The answer is no. They're the same molecule because it's just flipped. This is a mirror image. Let's look at the last example. Are these two compounds isomers? The answer is yes, because a double bond cannot be rotated. So this is locked in position, so the structures are different. Since the structures are different, these two are isomers. This is what we call a cis isomer, and this is a trans isomer. Cis isomer is when the groups are on the same side as the double bond. Trans isomer is when the groups are opposite of each other of the double bond. Learning check number 4. Given the compound, which structural formula represents an isomer? Pause the video, resume as completed. Choice 1 is wrong because this is single bond rotation. Choice 2 is wrong because it's a mirror image. Choice 4 is wrong because it's the wrong molecular formula. So the best answer is choice 3. Now I'm going to go over how to draw an isomer. Let's look at question 1. Tip number 1, avoid starting or working with N carbons. I highlighted the N carbons red. Let's say you want to switch these two groups. You'll get this compound. This is not an isomer because if you rotate this bond, you'll get the same molecule. Tip number 2, change or shorten the carbon chain length. Right now, the carbon chain length is 4 carbons. Let's shorten it to 3 carbons. We still have to put 1 carbon somewhere on this molecule. If we put it at the end carbon, it will be the same molecule as before because the carbon chain is 4. So let's put it at the middle carbon. The carbon chain is still 3 and it is a completely different molecule. So this is a valid isomer. Tip number 3, switch atoms from 2 different carbons. Let me first show you what happens if you switch atoms from the same carbon. So let's start at a middle carbon, highlighted red. Let's say you want to switch these 2 atoms here, the hydrogen and the carbon. You will get this molecule. This molecule is not an isomer because if you do single bond rotation, you'll get the same molecule as before. Now let's try switching atoms from 2 different carbons. So I highlighted the 2 different carbons red. We're going to switch the hydrogen from this carbon and this carbon that's bonded to this carbon here. By switching these 2 groups, we get this molecule. This molecule is an isomer. For tip number 4, if you have a molecule with a double or triple bond, you can move the bond around. Let's look at this molecule. It has a double bond. I am going to highlight the double bond red and move it around. So this molecule now has the double bond in the middle, and this is an isomer of this molecule. Just be careful that you're following the octet rule when drawing the molecule. For tip number 5, you can consider cis a trans isomer or a ring. For example, this molecule can have a cis or trans isomer, which are both isomers of this molecule. Here are the lists of possible isomers of this compound, and here are 2 examples of rings. Learning check number 5, given the compound, which structural formula is not an isomer? Pause the video, resume as completed. The answer is choice 2. Try to do the rest of the practice by yourself. Pause the video, resume was completed. Here are the answers. This concludes the video lesson. Remember to do the Juniper homework.